good. And actually, you wouldn't know it, but it's actually a technical tour de force. It's amazing what that movie, the people that made that movie were able to do with technology to make Tom Hanks appear in a video with John F. Kennedy. It was pretty amazing. In English class, interesting. If I were to be doing that in English, I would have read the book Forrest Gump in English class. It was a book before it was the movie. Oh, it's a great book. I highly recommend it. But if you're looking for a new book to read, I warn you, the book is written from Forrest Gump's perspective in the way he thinks. So, life is like a box of chocolates, and the way he thinks that way, that's how the book's written, as if that character were writing it. So it's a bit of a hard read. You got to kind of commit to it. Okay? Back to math class. Now, the reason I brought up what I just said, if you rely only on the formulas and you don't recognize what you're actually dealing with, then when you get to this question, you'll be in trouble. Because this question is a rectangular pyramid. And if you look on your data booklet, you do not have a formula for a rectangular pyramid, do you? You have a formula for a square pyramid, which works wonderfully. But if you don't know that it's made up of these 5 shapes, you're going to be in trouble. Which is why I teach both the formulas and the component parts. Everybody cool? Now, I heard all of you. We sorted it out. We all knew that Pythagoras was going to be involved here, yes? So it's a bit of a weird answer. LW is nice and easy. That's the rectangle on the bottom. That's just 32 by 48, correct? And our first triangle, we know the base of it is 32, yeah? But we had to find that first slant height, right? And that would have been this guy right here. I'll work in green. We knew this was 65. We knew this was 16. So this had to be the square root of what? 65 squared plus 16 squared. Then we get a square root, right? And that number goes right here. Now, please notice I am not actually putting the number there. Everybody with me? There's a reason. I don't want to go to my calculator more than once. The more times I go back and forth between my calculator and my paper, the more chance I have of making a mistake, right? You've all sent a text and typed the wrong thing, yeah? Okay? So, I am not going to go to my calculator until I can go to my calculator only once. Everybody with me? And I'll talk about why I think that's important in another second. Then I needed to find this guy. We knew that this guy, which I'm going to work in pink, was still 65, but it wasn't 16 anymore, it was 24. So this becomes the square root of 65 squared plus 24 squared. Go back to my calculator, or my equation, and this one was 48 times the root of 65 squared plus 24 squared. And then I would add it all up. Is everybody good? Now, is that a very good example of you showing me you understand this math? Yes. Mm-hmm. If you stop there, am I happy? So I'm doing that thing in comics where they draw the guy's face and it's like this on the mouth. Like you're not sure? Yeah? No. Because this is the math, isn't it? How do you get me an answer right now? Is it your math skills or your calculator skills that allow you to give me this answer? It's your calculator skills. Is this course called Calculator 10? No. Does everybody understand? I am more than happy if you're going to leave an open-ended question like that. Unfortunately, in every other course that you were doing calculations for, you need an answer, don't you? Right? If you were going to paint this pyramid, you need an actual number. You cannot go to Home Depot and say, hey man, I need 32 by 48 plus 32 times the square root of 65 squared plus 16 squared plus 48 times the square root of 65 squared plus 24 squared square feet of paint. Can you? No. Does everybody understand where I am going with this? If you find, as we are doing our work, that you never have the same number here as me, but you always have the work right, is that something that should bother you and make you feel that you cannot do math? No, it isn't. Because all that says to me is you need more calculator practice. And this is not calculator 10. Is everybody cool? As a matter of fact, after these first 2 units, you're barely going to need your calculator for the whole year. Okay? But these first 2 units, you're going to need them. So if you got to there, I'm cool. But then if you wanted to punch it in, you're going to punch that into your calculator. A great many of you will get a different answer here than me if you try to punch it all in at once. Why? Why?
Calculators, like, sometimes are different. Like,
Yeah.
if you don't put the brackets properly, it just messes up.
Yeah, it can absolutely mess up your whole answer. And who are you people going to believe? Your calculator or yourself? Be honest, you're going to believe your calculator. You're going to punch all this in and hit equals. And whatever number is there, you're going to write that on the test. Even if it makes no sense. So what can you do for yourself to get an idea of whether or not you have calculated correctly?
What I do, I bring it down to the answer. So I'll do 32 times 48, then I'll do 32.
So that's one thing you could do. You could go chunk by chunk by chunk and then add up all 3. Excellent. Is there anything else you could do? Let's say you want to try practicing getting it all in one go. Well, isn't this close to 30? Isn't this close to 50? So isn't this about 1,500? Yeah? 65 squared. Isn't that about 3,600? And that's 250. So isn't this about 4,000? And the square root of 4,000 is about 6.5, isn't it? 650? Everybody cool? Right? 32, 650. You could estimate across here. Now, will that give you this answer? But if it gave you something like 22,000, and then you punch it all into your calculator and you got 21,812, would you know you did it right? Do you see what I'm saying? You can have a good idea of where you're going, so you don't fall into that trap of punching in all this crap, hitting equals, getting an answer that makes no sense and writing it down. Everybody with me? Yeah? Okay. So did anybody actually get all those numbers like that? And did they get the right answer? Who wants to volunteer? Go for it. Sure.
7,004 feet squared.
7,040?
No, 7,004 feet.
7,004 feet squared. Anybody got anything near, far?
I have a different number because it depends on if you use a decimal or not.
True.
Absolutely right. That's the very next question I'm going to ask. Do I wish to get bogged down in how many decimal places do you need? Or do I want you doing math? I want you doing math. Now, if you do Ganika's way, she does it piece by piece by piece. This one's not going to give you a decimal. But these two are going to give you decimals, aren't they? Right? If she rounds off here, and she rounds here, that's going to give you a very different answer there than if you don't do any rounding here, right? If you leave this on your calculator and round at the end, you're going to have a different answer. Is it wrong?
No.
Of course not.
You don't mind that.
I do not care. That is why this stuff highlighted in blue is highlighted. That's what I need to see. Because that's what shows me you know what you're doing. Does everybody understand? Now, again, I ask you, is there any math highlighted in blue there that you don't already know? You've done length times width. You did it in grade 3. You've done Pythagoras. You did it in grade 7? 7? 8? Somewhere in there, right? Okay, last year. But it doesn't matter. You've done it, right? Have you done addition? Yes, you have. I know you're being fun, but let's be serious. Is there anything about that question that you don't know how to do? No. What makes it a grade 10 question? You're putting it all together. Right? Everybody cool? All right. Grade 8 was swimming. Damn it, I need to go right earlier. Grade 7 was swimming. Grade 8 was running. Grade 9 was cycling. Grade 10 is a triathlon. Does everyone understand? Good. Now, we need to check if that's right. I don't have a calculator handy. I do, I have 2 because I bought batteries for my calculators. 32 by 48 plus 32 times 65. Oh, crap. Sorry, my fault. Mistake. The square root of 65 squared plus 16 squared, close brackets, plus 48 times bracket, the square root of 65 squared plus 24 squared, close brackets, 7,003.97. Nice work. Go get a gummy bear. Okay. All right. She was right. If you didn't get that, where is your error? If you have that written out, where is your error? Is it calculator or math? If you got the same thing, then you're aces, right? Okay. Pardon me? 7,002? Fine. Is that close enough to that to make me happy? Do you think? Damn right it is. Now, let us move on, cabbages, to a cone. What is a cone? Everyone can make a picture of it. What is it? It's a triangle and a circle. But it's not really a triangle, is it? It's a chunk of a circle because it's got to go around, right? So if I was going to do the surface area of a cone, there's a circle on the bottom, right? We know the bottom of a cone is a circle. We've all had an ice cream. We know that. What gets me the area of a circle? Pi r squared. Plus, the other bit of it is a chunk of a circle. Yes? Everyone agrees? Okay. Since it's a chunk of a circle, what irrational number must be part of the area? Pi, because it's a part of a circle, yes? So I'm going to do something with pi. Now, since it's the area of a part of a circle, what other number must be part of it? The radius. Now, a whole circle is r squared. But this is not a whole circle, is it? So we can't do r squared. But you do know what this is going to be, because isn't a cone related to a pyramid? And how did we find the surface area of a pyramid? What measurement did we need? Not the height. We needed length times width for the bottom. But what number? We needed the length up the side, didn't we? So what do you think we need here? The length up the side. And that is the area of a cone, because it's a round pyramid. So I still need that slant, right? Now I'm going to give you a warning. I'm going to write it down right here. Slant height needs, oops, I forgot the D. I wrote NEDS. Needs what? How do we find a slant height that is unknown?
Pythagoras.
Right, it needs Pythagoras. Now, I am never going to call Pythagoras that horrible name that it is called nowadays. A squared, B squared, C squared. Ever. Because this is why. Even in honors classes, sometimes I do this. B, 9, and 12. And I ask them to tell me how long the hypotenuse is. And because I made the hypotenuse B, every kid gets it wrong. When they run it through Pythagoras, they tell me that this side is shorter than this side, and they actually hand it in to me. So that is why I do not use a squared, b squared, c squared. I call it what it is, Pythagoras. Now, fun fact about Pythagoras. When I was in grade 7 learning about Pythagoras, my teacher said, the square of the hypotenuse of a right-angled triangle is equal to the squares of the other two sides. And we all went, what? And he said, the square of the hypotenuse. And he just repeated himself. And we said, what is hypotenuse, Mr. Bailey? And he said, it's the longest side of the triangle. But how do I know it's the longest side if I haven't measured and done the work? Oh, it's the side across from the right angle. And I said, okay, what's that called again? The hypotenuse. And I said, cool. And then he said, if you can't remember what it's called, you can call it the hippopotamus. We do a whole unit on right-angled triangles. Comes to the test. What do you call the longest side of a triangle? Do you think I could remember? So what did I write on the test? Hippopotamus. What did Mr. Bailey give me? Wrong! 1987 to 2018. It still sticks right here. Son of a bee! That's okay. Mr. Bailey was actually a super teacher. I loved him to death. But, yeah, it hurt, man. It hurt. Okay, so what do I know in this cone? Do I have a radius? So I have an R. What else do I have? Height. Do I need height? Do I need height? What do I need? Slant. Slant needs Pythagoras, so I need height to find my slant, don't I? So what would it look like? Well, here's my cone. Whoop, whoop. The radius is 15, right? How am I going to find that slant height? Doing what we did right before, right? Something that you already know. You're going to make this red triangle. You know that's 15. What's this? 20. Jeez, Crystal. Relax back there. Holy. Najim, keep it cool back there for me. It's busting the place up. So this side right here is S, isn't it? S equals the square root of what? 22 squared plus 15 squared, right? Everybody cool? So now, since I know what S is, can I use my formula now? Pi, what's R? 15 squared plus pi, what's R? 15. And slant height, square root of 22 squared plus 15 squared. Is that the right answer? Yeah, that's cool. Can you tidy it up? Okay. 15 squared is 225 pi, right? And then the rest of this, I can't tidy that up unless I go to my calculator, can I? Right? I'm done. Now, here is where something is going to change for all of you. 1 second, Catherine. 15 squared is 225. It's pi r squared. 15 squared pi. Now listen to me and listen to me closely. You have been trained throughout your math career that pi is 3.14. Correct? It is not. Pi is a number that goes on forever and ever 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 and so on. You will no longer be giving pi as a numerical value. leave it as pi. Okay? Does everybody understand? Because this is an exact value. It's pi. You treat it like an x or a y. Everybody cool? Now, but Mr. Myers, what if it's a multiple choice test? Or what if I'm going to paint it? I need to know an answer. Then go ahead. But don't use 3.14. Use your pi button, which every calculator has somewhere on it. Everybody's got a different calculator. I cannot find everybody's pi button. Some of you will have a button with the pi symbol on it. Some of you will have a button with something else on it, Q, and the pi will be right above it. That's a second function. You push shift or second function, and then you hit that button. Everybody cool? I don't want you wasting a lot of time on that because I am perfectly happy with you leaving it like this. Really? Everybody cool? Pardon me? That'd be fine. Now, let's say you're doing a multiple choice test. Maybe for me, maybe for somebody else. And the choices all have values. 80, 831, C is 912, and D is 1024. I don't know if those are right? If that's the case, then you actually got to figure it out. But let me give you a hint. What's pi really close to? 3. 3, isn't it? So this is 675. 15 times pi is 45, plus 15 times whatever that is. Square root of 22 squared, 15 squared. You could get an estimate of that, add it up, and get something that was close. Is everybody with me? Sweet. So do not stress if your calculator skills are not where you feel they need to be. Everybody cool? Because I don't even care. Sadly, on the next unit, you can't do the next unit without having good calculator skills, but we'll fix that up when we come to it. Everybody cool? A lot of people, when I teach this unit, get scared because they can't make their calculator give the answers that I get because they're bad with their calculators. That's not bad with math. Don't equate the two. Everybody good? All right. Let's go on to the next one. And yes, Catherine, you said something, and then I said, hold on a second, and then I just talked forever. Don't let me do that. Tell me to shut up, Myers.
So I was just wondering, so if you can scroll up for a second.
Yes, of course I will.
So I'm looking at like the 22 to the power of 2 squared crap.
Yep.
Wouldn't there be 2 of those? Because there's kind of like, you split the cone in half, sort of?
No. Because really, the cone is this section of a circle wrapped around that circle. This part of the formula is that area.
Oh, okay.
Okay? You with me?
I think so.
Just like up here, on the nice easy one, each of those rectangles are right here. Okay? All right, let's go to a cylinder. What's a cylinder? We already talked about what a cylinder is, right? There's a circle, right? On the bottom. Then there's a circle on the top. And what separates them? A single rectangle, right? Well, what's the area of a circle? Pi r squared. How many circles do we have? So it's 2 pi r squareds, right? What's the area of a rectangle? Length times width, except the width is now wrapping around the circle, which makes it the circumference, doesn't it? What's the formula for circumference? Sure you do. 2 pi r, right? Because it's pi d. So the width is 2 pi r, and the length is right here, isn't it? Right? So if I pick up a cylinder, where's the length of that rectangle? It's right here, isn't it? Now, the way I'm holding the cylinder, what do you all want to call that distance? The height. Why? Because it goes from the bottom to the top, correct? So formulas are there to remind us, right? So I'm going to put H there. Oops, I wanted to change that color because I wanted to write the L in a different color. And what do I need to do with both of those values? Add them. Now here's the problem that is going to mess all of you up. Where's the height? Agreed? From bottom to the top, yes? Where's the height? If you say height is bottom to the top, where is the height? It's now the diameter, isn't it? So what is the height really? Talk to your neighbor and find out a way to describe to me what the height of something is. Because if it's bottom to top, when I turn it, the height changes. Go. And we're back. Who would like to share their definition of height? Not it. I don't want a number now. I want their definition of height. Manraj.
The distance between the base and the top.
Base and the top?
Well, that's what
Okay, so where's the top?
it's the opposite side.
I like, oh, what? Say that again.
The opposite side of the base.
The opposite face from the base. Thomas, what do you have?
I was going to say the height, the distance between the two circles.
The distance between the two circles. Excellent. What if I have an octagonal prism? There's no circles there.
Octagon polygons.
That. Preston?
Like the space between the part of the object that's closest to the ground to the object, to the part of the object that's farthest away from the ground.
From the ground? What if I'm in space? Am I still 5'8" tall?
From where your feet are.
From where my feet are. So we've had three definitions. Now, here's the interesting thing. Do we all know what all three of them were saying? Did all three of them say the same thing? No, he was talking about feet and something. He was talking about bottom to top at first, but then he changed his mind. And Thomas was talking about circles, but then I asked, well, what if it's an octagon? So really, what is the height? Because all three of them are right. Let's define it. What is height? The distance from what to what? The base. Now, when I say base, does that mean bottom? No, what does base mean? The side that we start from. Because if I ask you what is a cylinder, you're going to say it's two circles with a rectangle between them. So it has to start from a circle, doesn't it? So the circle's the base, no matter where I put it. So the height is the distance away from what we call the base. Not the bottom, but the base shape. Does everybody understand? So if I draw this cylinder this way, can we still do the math? Because where's the height? It's this distance from the base shape. If I draw the cylinder this way, can we still do the math? If I draw the cylinder this way, can we still do the math? Why? Because the height is always the same distance from base shape to base shape. Everybody cool? Get the word height out of your mind as anything but a letter we use to differentiate it from other sides. Everybody cool? Okay. So now, since we have that, we have a formula. 2 pi r squared, 2 pi r h. Now, where in this drawing of a cylinder What part of this is the 2 pi r squared?
The circle?
It's the circles. What part of it is the 2 pi rh? It's the rectangle. So if I told you this was a cylinder with no lid, what would change in our formula? It wouldn't be 2 pi r squared. What would it be? Pi r squared. What if I told you I was 10 years old and I was pretending to be a pirate? What would it be? Just the 2 pi rh. But Toya makes an interesting point. Well, then wouldn't it be this in here too? Whoa. Everybody with me? It depends on what the situation is. Everybody good? Does knowing that formula help you with every single cylinder you might face? No. Because you have to think about the situation for that particular cylinder. Everybody cool? Now this just says it's a pop can surface area. Does a pop can have a lid? Is that lid a circle? Does a pop can have a bottom? For math class purposes, is that bottom a circle? Yes. Does pop can have walls? So we need all parts of this, don't we? Okay, so what is it? 2 pi, what's the r? 5 squared plus 2 pi 5 times 20. Now, this is an example. This one has no decimals, does it? What's 5 squared? 25 times 2? 50. So this is 50 pies, yeah? Yum, 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 yum. What's 2 times 5? Times 20? Plus 200 pies. Yum, 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 yum. If I got 50 pies and I got 200 more pies, how many pies I got? 250 pie. That is the answer I want. Does everybody understand?
So if we were to actually do 250 times pi, you would still accept that?
If you need, some of you are incapable of accepting this. Your mind is just, I need a number, Myers. I need the number. If you need the number, it is just 250 times the pi button. Now, of course, pi is almost 3. So when you do the work, your answer should be near 750, right? And when you do this, it comes out like 773 or some crap. I don't even know. I don't care. It doesn't matter. 785?
Yeah.
785.3. For all the people that can't do this. Now, if you are one of the people that cannot leave that as an answer, I am very sorry for you. Because very soon you have to leave that as an answer. Yeah. And you're going to be like, stop it. I can't do it. Because this is an estimate. Because your calculator screen is full of garbage. And how long will that decimal go? If your calculator screen stretched from McKenna's desk to Pluto, would it be all full of numbers? So will you ever be able to tell me the actual surface area of that cylinder? No. This is the actual surface area of the cylinder. Understand? Now, I know it's going to drive some of you batty, which is why I don't care. But I am warning you. In the future, you will be leaving pi as pi. You will not be cutting it up and giving pieces to anyone. Okay? Preston, hit me.
How do we know if pi is infinite? Like, how do we know that?
We don't. We assume it is. Because when you take the circumference of a circle and divide it by the diameter, every single circle in the universe gets the same value, 3.14159 for the first something like 3 trillion digits. It's always the same. So we are assuming that it will carry on. But we don't know because nobody has tried. Now, people are trying. There's a computer that's been doing decimals of pi since the 60s. Now, just out of curiosity, yes, Thomas. Bathroom? Go, leave, what? Oh, answer. I believe so. There's a computer at MIT or some weird math place that has been dividing the circumference of a circle by a diameter of a circle for like 50 years. Yes. Now, I don't know. No. We'll say no. What was I saying? Where was I?
50 years ago.
50 years of pi.
In the computer, it's been doing it.
The computer's been doing it for... Oh, I remember where I was going with this. Some guy... How many of you have ever made an Excel spreadsheet? Excel, a spreadsheet on Excel or on Google, right? On Excel, you can slide down, and the row that just keeps adding rows, doesn't it? Some dude just wanted to know how many rows are on an Excel spreadsheet. So he put the mouse on the little arrow, pushed down, and just sat there. 9 straight hours. The end of an Excel spreadsheet is row like 1,583,000. That's a big ass spreadsheet. But it does end. It's on YouTube. Like the guy sat there. He ate while he was doing it and stuff. No. Huh? I don't know, because I didn't watch all 9 hours of it.
How about you skip to the end?
So use your time wisely. Or not wisely, because that's a real waste of your time. Now, okay. Listen, please. It is 2:06. You have 20 minutes left in class. Now, I lied when I told Thomas there would be no homework, because there's a worksheet right here. What are you going to do, right? Maybe he'll watch the video, but he probably won't. Somebody is friends with Thomas. Somebody shoot him a text or an Instagram or a Snapchat or whatever the hell you people are using to talk to each other. I don't know what it is. Some weird... Maybe one of you will send him a MySpace. I don't know. Is MySpace finally gone? You know, it's ironic that MySpace should be gone because it ain't no different than all the rest of the crap that's out there. It's the same damn thing. But, it's MySpace, so it's old. It must suck. Right? Yeah. Oh, nobody uses Facebook but old people anymore. What do you use? Oh, I use Twitter. Oh, so you talk to other people over the internet with letters? Yeah, that's really different than a Facebook post. Yeah, it's totally different. Only get 147 characters, so it's lamer. No! Anyways. Yes, I'm well aware of that is what you all think it is. I know. Doesn't matter. I don't use any of it. When I need to talk to my friends, I talk to them. And my friends are actual friends. People that I know who they are. Not necessarily an 87-year-old man in Grozny, Poland, who's pretending to be a 16-year-old girl who you're friends with. Right? I think Grozny's a city in Poland. Now I want to know.